Hi all, this is Alan with Bothell STEM Coach, and today we're going to be looking at the 2017 BC Calculus BC free response questions, and we're looking at number 2 here. And this is the calculator portion of the exam. So the figure above shows the polar curves. R is equal to 1 plus sine theta cosine 2 theta, and that's R here. And let R be the region the first quadrant bound by the curve F. So this one is R. And let S be the region the first quadrant bounded by the curve these two. So S is just between these two. So S, yeah, okay, between those two, gotcha. Find the area of R. In general, the area of the R is 1/2 R squared d theta. So that's the integral of 1/2. In this case, R is just the distance from the origin to our curve. So R is equal to 1 plus sine theta cosine 2 theta squared d theta. But I have to figure out what the bounds are for this, and they tell us it's between 0 and pi over 2. So I'm going to go 0 to pi over 2. Okay, so since this is a calculator portion, we can do this integral. So we're going to integrate 0.5 times 1 plus sine x cosine 2x squared, integrate over x, and go from 0 to pi over 2. So we get this area to be 0.648. Okay. The ray theta equals k, where k is between 0 and pi over 2, divides S into two regions of equal area. I'll try to eyeball it, maybe about there. Well, theta equals k. Okay, so it divides it to where this region and this region have the same area. Write but do not solve an equation involving one or more integrals. Well, the whole area of S is given by the area of the bigger arc minus the little arc. So when we do this area pi r squared, it's really pi, the big R squared minus little r squared d theta. That would be the area. So what we're going to do is we're going to do 1/2, and the bigger R refers to the R to the outer curve here, or g of theta. So g of theta is given by 2 cosine theta squared minus 1 plus sine theta cosine 2 theta squared d theta. Now, so this would be the area, okay, of the curve. Now, we're only, if I want to do this first part, I just want to go from 0 to k, and I want to set that equal to the integral, the exact same area, but I'm going to go from k to pi over 2. Because the setup is the same. The r squared, the difference in the r squared is the same. It's just this part compared to this part. And the second integral goes from k all the way to pi over 2. So this is my setup right here. Kind of a big, long, messy one, but that's it. Okay, for each theta, 0 is less than or equal to theta is less than or equal to pi over 2. Let w of theta be the distance between the points with the polar coordinates f theta and g theta. So it's like, so for a given theta, like here, for example, the distance w of theta would be this part right here. This would be w of theta. Write an expression for w of theta. Okay, so w of theta is just the difference in the r values, right? Because it's just this length minus this little length here. Sorry, you guys can't really see that. Let me, it's this length minus this little length here. So I'm gonna do this big length minus this little length. This like this part here is g of theta, and the longer part is f of theta. So w of theta is just the difference. And g of theta, what is g of theta given by? So that's 2 cosine theta minus f of theta. So minus all of this, minus 1 minus sine theta cosine 2 theta. So that's w of theta. And WA is the average value. How do we do average value? I do 1 over the width of the interval times the integral from that of interval of w of theta. And so that's 2 cosine theta minus 1 minus sine theta cosine 2 theta d theta. Okay. So math here. We're going to do 2 cosine x minus 1 minus sine of x cosine of 2x. Okay. Going to integrate from 0 to pi over 2. Sorry, integrate over the variable x. Integrate from 0 to pi over 2. And then I need to divide that by pi over 2. So WA is equal to 0.485. Okay. Using the information from part C, find the value of theta for which W of theta equals WA. Is the function W of theta increasing or decreasing at that value of theta? So I want to know when 2 cosine theta minus 1 sine theta minus 1 minus sine theta cosine 2 theta is equal to 0.485. Okay. So that's what I want to find theta. Now this you can just you can plot the graph 2 cosine theta or x minus 1 minus sine x cosine 2x. Okay, and I want to, let's see, graph, and I'll probably want to affect the window a little bit. So I want to know when it's equal to 0.485, right? Calculate. Can't calculate, you can only calculate zeros. So the way you want to do it if you want to calculate zeros is I just got to subtract the value. This is like a trick you can do. Because I subtract 0.485, then when I graph this, where the zeros are is what I want. I should have windowed it. Because I need to only go to pi over 2. That'll make it easier. So let's make it 0, and then pi over 2. And then x min, we'll do minus 5 to 5. I don't know what the exact values are. I guess I could have thought about it for a second. I want to know what the zeros are in this case, though. Yeah, it's not zoomed in enough, but it's okay. The calculation can find the 0 for me. So now I'm going to find the 0. Just make sure we're above it. Here I'm above it. Below it. So this happens at theta is equal to 0.518. Okay? And I want to know if it's increasing or decreasing at that point. I just need to take the derivative of this and then plug in 0.518. The derivative of all of this is negative 2 sine theta. So W prime of theta is equal to negative 2 sine theta. The derivative of 1 is 0. The derivative of sine and cosine, so I'm going to subtract, and then I do product rule. Sine theta times the derivative of cosine theta, that's 2 sine 2 theta. There's a negative sign in front. Plus the derivative of sine theta, which is cosine theta, cosine 2 theta. Okay, so that's minus 2 sine theta plus, this negative cancels with that, plus 2 sine theta cosine sine 2 theta, and then minus cosine theta cosine 2 theta. So if the derivative is positive, then it's increasing. If the derivative is negative, it's decreasing. So let's do this. Negative 2. It looks like from the graph it was decreasing, but it's just good to just plug this just to be sure. Plus 2 sine 0.518 sine of 0.518 times 2. So that's that plus, and then minus cosine of 0.518 cosine of 0.518 times 2. So this is equal to negative 0.581, so that's less than 0, so this is decreasing. Okay, so let us take a look at the solution manual. So 0.648, that's what I got. This equal to that, or I had the 1/2 in front, which is fine. Or it's 1/2 of the total integral, or you did this is equal to this, or you can have a 1/2 in front. Either is fine. W of theta is that 0.485. Is that what I got? 0.485 over here. That's good. And then W of A is 0.518, and it's decreasing because W prime is negative. So that's it. Hope you found that helpful. I'll see you in the next video. Thanks for watching the video, guys. Please leave a comment, like, or subscribe below to catch up more of the content. And see any links below. I offer free homework help on Twitch and Discord. See you guys in the next video.